that's where we're going to launch off today using several transformations. Starting with the subtraction of 2, obviously, to get rid of that. Simple, easy, yes. X minus 4 is 6, okay. What are we going to do? Well, the inverse of the subtracting 4 is what, guys? Yep. And in doing so, we end up with our answer. This here is the inverse, and it undoes the subtraction of 4. All right. So these have addition going on. This one has subtraction going on. Maybe 6x equals 24. That's multiplication. 6 times what number is 24? Well, to undo multiplication, we divide. And remember, whatever we do on one side, we must also do on the other. So this is the inverse of multiplication. And the last quick little reminder, x divided by 3 is 2. We are dividing here. The inverse is going to be to multiply. And you multiply by 3 over 1 or 3. On the left, that 3 over 1 cancels the 3 in the denominator, giving you what? X is 6, yes. And that was the inverse of division. What that has to do with today's lesson is oftentimes you have multiple things going on. You might have addition coupled with division or subtraction coupled with multiplication. And the question of the day is, how do all of these things work together if you're faced with several such scenarios? So that's what we're going to work through today. Here's example 1 for you. So let's take 2x minus 7 being equal to 4. So we've got a subtraction activity as part of the equation, and we have multiplication, all smashed into one equation. What thing do you do first? Well, the thing you do first is you undo the addition or subtraction piece. Which would be the minus 7. To undo the subtraction of 7, we're going to add it, leaving us with 2x being equal to 11. You might be saying to yourself, well, that doesn't look right. That's not going to come out to something even. It's okay. You're not always going to have even answers anymore, or whole number answers, I should say. After you've undone any addition or subtraction, you undo any multiplication or division, which in this case, it's multiplication, so we're going to divide. You can leave me with this answer. Converting it to 5.5 is acceptable as well, but you're not going to find that in the back of your textbook anymore. You're going to find this. Okay? Now remember, they might mix addition with multiplication, subtraction with division. It doesn't matter. Nor does the order even matter, and I'm going to show you that as well. Let's take, I'm going to flip really quick. Seven plus 4a equals 31. Or I could have said 31 equals 7 plus 4a. You might not recognize this, but that 7 is going to be treated as if it were an addition. Because what this is a positive 7 and a positive 4a together equaling 31. So the thing you're going to do here The add subtraction piece is what? What do you think we're going to remove? This is multiplication. This is addition. So since you do your addition subtraction first, what are you going to do first? Subtract 7. Good. So if something is attached to a variable, whether it's this or as a numerator denominator, then that means it's either multiplication or division. So multiplication might look like this, and division might look like this. These are all examples of a multiplication division step happening. Okay? If a number is by itself, it is either addition or subtraction depending upon the sign. Anyway, what did we get? 4a equals 24? What am I going to do to undo what's happening here, Lee? Divide by what? Yeah. Undoing the multiplication by division. Looks like that, right? So here's another example, and there's so many different scenarios that you're going to be faced with, and all you have to tell yourself is, so what if it looks different? What does that mean within the rules? Here's another one. 1/5 multiplied by x minus 9 is equal to 3. What are we going to do here first? This one's kind of obvious, but what are we going to do first? Add 9 to undo the subtraction of 9. And remember, whatever you do on one side, you must do identically on the other. 1/5 of x is equal to 12. What am I going to do now? Multiply by 5 because you want to divide. Technically, this means 1/5 multiplied by x, but you cannot divide by a fraction. Instead, you multiply by a reciprocal. The reciprocal of 1/5 is 5/1. This, in effect, cancels these out because that becomes 1. So 1x is equivalent to the value of the product of 12 and 5. Boom. Done. There's your answer. The rest of this entire lesson only gets a little bit juicier, but not really more difficult. I'm going to see if you guys can figure this out. The difference of k and 4 cut in half is equal to 13. Now, if you recall up to this point, I've said to you guys, always do your addition or subtraction step first, which might lead you to believe, okay, add 4 to both sides. But the conundrum here is the fact that we're dividing that difference in half. So when there is a grouping symbol, you must deal with that first. So that's where the order of operations kind of comes back into play. So instead of dividing, or instead of thinking about the 4, we're going to deal with the fact that this is being cut in half. To undo it being cut in half, we're going to multiply both pieces by 2. That will cancel out the 2 on the left, leaving us with k minus 4 being equivalent to 26. Now it's easy, add your 4. You okay over there? Good? Add your 4. So that leaves k being 30. And you could check yourself by plugging that k value right there where the k is in the original equation. Examples 4 and 5, and then we're going to be done. Here's example 4. 40 is equivalent to 2x added to 3x. What does that mean? Well, what do? Well, we divide by the 2 or we divide by the 3. Nope. If you can, you must simplify first. As in collect your x's, your liked terms. Collect your like terms. Good? Okay. The sum of 3 and 2 is obviously 5, which means there are 5x. Right? Now we go back to the norm. Divide by what, guys? Good. The value of x then is 8. Example 5 is simply bigger, badder, little more work involved. You need to be careful. Example 5, and this is kind of the end of your assignment where these will come into play. 8 multiplied by the sum of w and 1 minus 3 is equivalent to 48. Oh, we need to add, or what do we need to do? If you can, you always simplify first. And you can. Now I want to draw your attention to this distributing the 8 thing. On several of the assignments I handed back this morning, there were errors in how you're distributing. You're not taking into consideration positives and negative numbers. Obviously that's not an issue here because everything's positive, but you need to be very, very careful. If this is a negative, how it affects the result of the product. Anyway, 8w added to 8 minus 3 is 48. Can we still simplify here, folks? And if so, what? Are there any terms that can be collected that are the same kind of thing? Lee? Say again? Nope, that's a variable. That's a number. The 8, what else? Why is he saying 8 and negative 3? What are they? They're both what? What is this, Lee? And what is this? Can you combine numbers? Huh? Good. You end up with that. And yes, this is going to be an ugly one. What am I going to do first? Back to the original example 1. Good. And what now? Divide by 8. W is equivalent to 43 over 8. You don't have to give me the whole 5 and 3/8. You can leave it like this. This is how it's going to look in the back of your textbook when you look at your odds. Now, look at the assignment for today, and we'll talk about that for a minute.